In this video, we demonstrate our visual analytic tool, VASA, for interactive computational steering of large asynchronous simulation pipelines for societal infrastructure. Our VASA workbench consists of multiple coordinated views, a calendar view, an event view, a geographical view, and a pixel view. Here, we are adding hurricanes from the list to the event timeline. For a simulation, Hurricane Irene is selected from the calendar view. In the event timeline, we can select different dates to see different estimations from our proxies. Currently, the user is selecting dates ranging from August 20th, 2011 to August 29th, 2011. As the path changes, our infrastructure proxy shows instant damage estimation. Here, blue means intact, yellow means damage expected, and red means disabled restaurants. Now, the user is checking all paths of Hurricane Irene. In order to see the estimation of Hurricane Sandy, we add Hurricane Sandy to the event viewer. Then we choose different dates ranging from October 22nd, 2012 to October 30th, 2012 to check the estimated damage caused by Hurricane Sandy. In order to compare estimations of the two hurricanes, we fix Hurricane Sandy on October 27, 2012, where Hurricane Sandy affected on some restaurants in northern North Carolina, and also fix Hurricane Irene on August 24, 2011, where Hurricane Irene affected on many restaurants in eastern North Carolina. Then, a foodborne event that lasts for 3 days can be simulated after hurricanes. In this visualization, we use kernel density estimation to present ill people around restaurants. The darker the area, the larger the number of ill people are in the area. The matrix view presents information on which food processing centers supply to which restaurants. Here, the x-axis represents different restaurants, and the y-axis represents different food processing centers. A pixel presents the amount of food supplied. The darker the red in the pixel, the larger the amount of food is provided in the restaurant. By selecting a region where we see a hotspot, we can see which restaurants are in the hotspot and what amount of foods were delivered to which restaurant by which food processing center. Next, we will briefly demonstrate a scenario of the supply chain in hurricane season that requires complete simulations. Here, a hurricane consists of 3 polygons, and each polygon has a different wind speed. Here we fix Hurricane Irene on August 27, 2011, where Hurricane Irene passed directly across eastern North Carolina, an area with many power generating facilities. Here, the power generating facilities are in purple in the geographical view. Currently, the wind tolerance values for these facilities are 34 knots, that is the wind speed of the outermost polygon. Here, our proxy instantly estimates which restaurants will be impacted based on the relationship between the units and the restaurants, coloring the impacted restaurants red. Then we initiate a complete simulation on power outages and transportation network damages. Here, a polygon appears presenting an estimated power outage area that will be sent to the routing components for new routes computation. Then we initiate a simulation run for rerouting. Here, we see the new routes for food delivery that exclude restaurants in the impacted area.